With MongoDB 3.4, we now offer intra-cluster compression, that is, compression for network traffic between the servers in a cluster. When does intra-cluster traffic occur? Consider a replica set. Each write operation performed on the primary is transmitted over the network to all of the secondaries in order to maintain consistency. Similarly, in a sharded cluster, the MongoS processes are used as routers to forward network traffic to the appropriate servers. Replication and MongoS traffic can cause saturation when transmitted over a network with limited bandwidth. Additionally, in environments where purchasing additional bandwidth is costly, this traffic can significantly increase the total cost of ownership of a MongoDB cluster. Intra-cluster compression helps mitigate these problems. Just to be clear, this compression does come with a trade-off. It uses some CPU cycles to compress and decompress the traffic, and the amount of CPU depends on the compression algorithm. Currently, we only offer Snappy, which prioritizes speed over the compression ratio. In cases where CPU cycles are worth the trade-off, either because bandwidth is a bottleneck or because it has a significant marginal cost, intra-cluster compression can be turned on. In cases where CPU cycles are a bottleneck and bandwidth is not an issue, it might not be worth the trade-off. Doing a rolling upgrade for this feature shouldn't cause a problem, by the way. Servers with intra-cluster compression enabled don't need to use it. They only will if the server or router on both the sending and receiving ends are using it. Otherwise, they'll simply communicate without compression. Now that you know a little bit about it, let's take a look. Let's take a look at a script I've prepared. If we scroll down a bit, we can see that this script will spin up a replica set with the ---- network message compressor's snappy option set. The important thing to take away from this is that intra-cluster compression needs to be turned on while you're starting up your MongoD or MongoS process. You can either invoke it on the command line, like we're doing here, or you can use a configuration file. Check the documentation for details on how to do that. For now, let's run this script. Next, let's log into the shell. First, I'm going to insert some documents so that we can see some of the effects of compression. Now that we've given our replica set something to compress over the wire in its op log, let's look at our server status. Now, this is a huge document, but I just want to look at a small part of it, the network subdocument. Here, we'll focus on a few fields to give you a sense of what you're looking at. Physical bytes in or out represents the total number of bytes taken off the wire or sent over the networking wire by the networking code. Bytes in represents the total number of bytes passed to the database logic of the MongoD or MongoS. The compression stats treat each compressor like a machine. So bytes in are the number of bytes passed into the compressor. The number of bytes for the compressor won't ever add up to the physical bytes in or out because they don't include the headers for each network message, only the bytes actually passed into the compressor. Keep in mind this is a snapshot in time, and this describes all network activity since the server was started. And that's how intra-cluster compression works and how you can look into what it's doing.